Hi, all you just joining, welcome. So today this is day four, but lecture three of Harvard's CS50, and today we're covering exceptions. So I'm going to be starting in a couple minutes. I joined today late, but I'm going to start in a couple minutes, and yeah, just maybe share the live, like it, so that if you know any other person that'll be interested in watching this, they can tune in. But before we jump in, so before today, the things we have covered functions and variables, conditionals, loops. So if you have any issue with any of these three, four things I just listed now, you can just ask your question. My network is breaking. Oh, let me. Is my network okay now? Is the network okay? All right, so let's just jump in. I have too many files opened up. Um, all right, so in programming Python especially, there's this stuff called exception handling. It's the process of catching errors in your code before the code runs, or catching error in your code while the code is running. Now, I don't know if this is generalized or programming language, but for Python, there are two main types of errors, and under those two types of errors, there are now other categories of errors that have been grouped. So the two main types of errors are syntax errors. These are errors that are made by you. For example, if I'm writing what is this? Oh, what is this? Okay. Alright. Sorry. So for example, if I'm writing a Python code and let's say I know the right syntax, maybe I didn't close my parentheses, I didn't indent my code where it was supposed to be indented, I didn't close it with the I didn't close the inverted commas, I didn't like all these base, like just the syntax of your code, the way the outline of the code is supposed to be. If you as the developer made any error in any of these fields, it's going to prompt a syntax error. Now there are different types of syntax errors. It may be even if you tried accessing a variable that didn't exist. That is one of the most popular one. That is a name value error, be value name error, whatever. You are trying to access a variable that hasn't been declared or defined yet. Or all these other types of errors are already called like indentation error and many more. But one of the main errors, the main one when you do this syntax errors, you don't use exception handling to catch syntax errors. Whenever you get a syntax error, you go and you fix that yourself as a developer. But exception handling is used to catch um runtime errors. This is when you're saying, for example, my program is working very well, but now you can never be in the mind of everybody that's going to use your device. You don't know what the person, like, you don't know if the person that is using your program understands the prompt they are giving them, or if they are going to input the right value. For example, you want to get an integer and the person is imputing strings, or the person is imputing floats. So when you want to now catch all these errors to avoid your program from crashing, especially if you have like a long list of things to run further, you make use of um exception handling. Now I made a quick chat, so I wouldn't really forget what I want to cover. So you have, okay, this one I've covered: syntax error, runtime error. Now this stuff on that below here, where you have your try, except, else, raise, and finally. These are all the things that makes up um should I call it the blocks of the, or your process, or your functions for carrying out exception handling. Now, the main and most popular one you always come in contact with is the try and except. We're going to jump into that shortly. And then there is the else statement, your raise, and your finally. So let's jump into try and except, because you cannot define a try statement without having your except. So let's work on the first input I prompt you for earlier. Let's say we want to receive an integer from the user. So normally what you would do if you want to receive an integer is to define the variable you want your input to be assigned to. And then since you specifically want an integer, you're going to pass the int function before it, and then get the input from the user. So by just doing input, and maybe you can give a prompt to the user so that they can know what they're doing. Okay. Now, if I want to now maybe display whatever the user has imputed before, I can simply just do print, and it is x I use, print x. So this is going to receive an input from the user and display the input that the user imputed to them. So this is basic Python. Everybody that is currently with us at this point is already familiar with this code. But what if, okay, let's run it. Let's run the code. So I know, since I'm the one running it as the developer, I know that what I want to get as the input is a number, an integer, not just any number, because we have floats. We have, why do I keep forgetting what that last number is, when you have 3ij, this imaginary number. I keep forgetting what they call it in Python. But you have that also as a type of number. You have decimals, and then you have integers. So I don't just want to catch any random number. I want to catch an integer. So since I'm the one who wrote the program and I know what I need for my program to run smoothly, I would surely input an integer here, for example, 5, and I run it, and my code runs perfectly. There's no error. It didn't crash at all. But what if the person who was using this program, let's say the person didn't understand English, because like, okay, if you give, like, when you're playing some games, they'll give you prompts and guides on how you should make use of their program. So what if a prompt was given to you, a guide was given to you to show you how to use or how to access the program, or what input you are supposed to give? Quite right, there are a lot of programs do that. But what if the person using it doesn't read it? Because me, for example, I would hardly ever read the prompts they are giving me to use your program unless I get lost. So what if the person that is making use of the program currently didn't read those? Or what if the person doesn't understand the language that your prompt was written in? What happens next? This is when you, okay, let's run it. Let's pass in an error here. Let's receive an error. Let's say let's just pass in any normal string, and we can see it raised a value error. So now this value error is one type of error under the runtime error. So you have like I'm just going to like there's a lot honestly, maybe not too much, but I don't know every single thing of heart. The one, let me be honest, the only ones I have on my brain right now: zero division error, value error, this stuff. Uh, to be honest, I actually don't have them on my mind. Usually, you can go and Google it, you see everything there. So usually, sometimes if I just want to catch every general error, I'll just while I'm jumping ahead of time. Okay, let's handle this error first. As we're handling it, I'm going to explain what we're doing. So instead of getting an error every single time because it's going to crash my program, what if getting this number was just the first part of the program and I wanted to use this number to do like a whole lot of calculation and now my program is crashed? So what is going to happen? That means users will never be able to make use of my program because it's crashed. Like sometimes I come across that before. But what I would do in this case instead is to pass in this try is this statement of function or call it honestly, I don't know. And I will indent it. So since I'm indenting it, I'm not going to indent this code over here. So I've done try this. So I'm just telling the function, take this code I'm giving to you right now and try it. Then what should happen if an error is raised? You can see my try is still on the is still on the line red because I said whenever you call try, you call except. It's not like when you're working with if else that you can just run if and forget about the else, and whenever you need else, you can call else and now run it again. Whenever you run try, you run except. They work hand in hand. So if I call try, I'm not going to call except. So now the next thing that follows this except, that I can either leave it blank. So if I just call except and just indent it and jump to it and start the code block, what is going to happen is that it's going to catch every single error, even errors that you didn't think possible. It's going to catch those errors. Come on, let me change my network. I think my network isn't behaving. Okay, what was I saying? Right, so when you just call except as a block on its own, what it does is it catches every single error. It will catch all the errors, not every single like every single runtime error. Yes, that is a better way to phrase it. It will catch every single runtime error that has made an appearance in your program, whether you knew it was even there or you knew it was even possible to get that error. But even I want to specify it specific, like maybe for example, I want to get different errors and let the user know what was wrong with their input. So I want to kind of like guide the user so they will know what mistakes to not make again. And I feel this is one problem I have with a lot of people's program. I would like, especially when you're logging into forms, I'm writing an input, maybe I'm writing the username or something, and they'll just prompt an error to me and they'll tell me login error. They wouldn't tell me what caused the error, they'll just tell me login error. How exactly am I supposed to remedy the error I made if you're not telling me what the error was? That's why sometimes it's good to just pass it to except. Maybe you don't want to pass for every single thing. So sometimes what you can do, because you can call except block multiple times. So you can catch the first error, catch the second error, catch the third error. Maybe those are the three main errors you want to catch. Catch all these errors. Once you're done catching it, you can now just for I don't know, for security's sake or whatever, just call the except block as its own feature at the ending of your program to just catch every other error and maybe just because those errors are not really important to the case. It's just in case of. So if I want to catch a specific error, which in this case the error we got is a value error. If I want to catch this value error, I'll just pass in value error the V and the E whenever they are making use of this what do you call this topic again? I've forgotten what they call this case. This case when you have capital letter, like for every first letter of every word is a capital letter. I've forgotten what you call it. But that's how we're going to use it. Or you can even just if you come here into your terminal, you see the way the error was called. You can just copy that and just paste that into your except. Oh, there's this system interrupt error. Yes, that one is when you are going to make use of controls. Is it control C or control Z in your program? So you can use that. Like that one will come in handy when you want to start working with receiving multiple input from a user. Maybe you want to take a large amount of input from a user and compile it into a list, and you don't have a set amount of how many things you want in the list. So you can just tell the user to keep passing input until this stuff error until the there's a word they call it there's a word they call it until that error is received. Once it's received, is it keyboard interrupt? Yes, a keyboard interrupt error. So until that keyboard interrupt error is received, continue running. And once it's shift, you can now get all the value that has been passed in, since you just be appending it into a list and you can now work with it wherever you want to work with it. But I'm jumping ahead of myself. We are going to work on a project where we are going to see that. Not today, probably though. So now I've caught the value error. So what should we do if we have what should we do with this value error now? We can do different things. We can end our program, we can exit. There's a function in Python called exit. There's also a function called sys exit, and I think there's also os exit. So we're just exiting from your program. We're just saying quit, close the program, we're done with the program, or end the program here. Or we can give the user an error message and then prompt them to try it again. We're going to get into that shortly. Or for now, let's just throw in an error to the user and end our program. Let's just print let's just print run it first here. Let's run forward add another thing to our program. Now let's run our program perfectly by passing in a normal integer. Let's pass in a very basic integer. It ran perfectly fine. Now let's try um getting an error from the program. So you can see now we are getting another error here, name error. So we have worked with value error. Now we are getting name error. Now remember I told you this name error is a syntax error. It's not a runtime error. So the name error is not a fault on the part of the user. It's a fault on us, the programmer. So what is happening here basically is we created our program which took an input from the user and assigned that input to a variable called x. We now access this variable called x and ask them to print x. But the thing now is when we said when we now handled value error, we didn't assign anything to x. I could have decided to maybe pass in a default value for x. I could have maybe continued prompting the user to keep passing in their inputs, or I could have ended the program after we handle the exception error. All these things work fine. So let's take each and every of them individually. Giving setting a default value for x, I feel that one is a very basic thing to do. It's just after you set accept value, just under print, you may just say x is equals to 9. So if the user imputes anything that isn't an integer, the default value is going to be 9 and it's going to print 9 instead of whatever error it is the user imputed. So this one is a very basic one. So you see, it printed 9 instead. But what if we don't? What if it's something that we cannot really get like a default value for? It's something that we cannot just set a random default value and expect it to handle our whole program. So let's go for the first one. Let's end the program. After we have prompted the error to the user, let's just exit the program. I think another alternative for this exit is quit. I personally don't really use it, but let's see it. Did I run? Okay. So you can see after it prompt value error, after I told him that there was a like it prompted this print value I called, the program ended. So even if the program still broke on its own, which is what we're trying to avoid, so we're going to jump into that shortly. Even though the program broke on its own, it's not giving us this ugly code. Let me see if it's still here. Let me scroll up. So you're seeing these ugly messages is prompting us to let us know that an error was made. So we're still letting the user know that they messed up one way or the other. But we're not throwing all these large amount of codes at their face because most of those users are not even developers. Most of those users probably don't know what error they're getting. So they'll just think your app is faulty and they will not know they're the ones at fault. But with this, we're trying to prevent ending our program whenever a wrong IP is received. Because basically, what is happening is the exact same thing that system is doing. We're just making it final. We don't want our program to end. We want our program to continue. This is where we're going to take from the last. Because I think it was on Thursday. Because I don't think I came live on Friday. So I think it was on Thursday when we covered while loops. Because we covered for loops the day. Oh no, we covered for loops and while loop that day. But we're going to make it a while loop. So if you remember, the whole idea of while loop is sorry, give me a second. Okay. Um, the whole idea of while loop is that you set um a statement. It has to be true or false. Even if you are not throwing true or false, you are going to throw in like, is this equal to this? Whenever you are making use of this comparison or whatever, it's a true or false. Yeah, the output that the system is getting is going to be either true or it's going to be that false. So the way while loop works is that it runs while either something is false or while something is true, and it's going to continue running until that function has been interrupted. And I think I use so your program is going to continue looping. That's when you now start hearing about infinite loops, I mean infinity loops, like loops that go on forever, they never stop. And that can crash your program because you don't know what the size of your system is, and you don't know how large your system can run before it crashes. Hi. So you want to prevent that. So you now I'm now diverting back to loops. I think I uploaded the video of loops on my YouTube, so you can go there and check it. I have a playlist called CS50 or whatever the place is called, but it's CS50 something. So back to where we are. So now we want to run this try. We want to keep getting the input from the user. We don't want to end our program when an error is received. So we're going to remove that exit. And now we're just going to come here and let's just enclose all these blocks we just created. I don't know. Oh, regular expression. Yes, I made a video on regular expression. I think I've made two videos. Oh no, a video. I've made a video on regular expression. So we want to enclose this code inside the while loop. So we're just going to call, let's just say while true. Why is it capital letter? The T is in capital letter. We're going to call our column here and we're just going to indent every single thing here, excluding the print function. I've not done anything to handle that print function yet. So we're going to jump into that tomorrow. This is well right now we're doing Harvard's course. We're doing CS50, this Harvard introduction to programming with Python. So this is what we're on right now. So maybe after we finish this series, I can revisit regular expression. But if you check my YouTube, I have a video. Let me check. I have a video on regular expression on my YouTube. Network is so bad. While it's loading, what was I saying? Okay, so I'm going to now enclose our try and accept block into the while loop. So what I'm saying is while this statement is true, run um okay, see the CS50 place I was talking about, CS50 introduction to programming in Python. But if you check into my playlist, 10 days Python crash course. That is the last one I did. That was day 10. So day one, basic concepts of Python. Day two, input and strings. Day three, control flow. Day four, functions and models. Day five, file handling. Day six, arrays. Day seven, object oriented programming. Eight, recursion. Um nine, we made the rock paper scissors game. And then on day 10, that's when we visited regular expression. See it here. Day 10 is when I visited regular expression. So you can go and watch that one. You can go and watch that video. Then maybe after we're done with this, Harvard, or maybe I'll see if I can go live in the afternoon. Then I'll touch regular expression in the afternoon. But that depends on how tomorrow would be. But right now, I'm doing this Harvard's introduction to Python programming. Okay. Um. So let's run it like this first before we jump into anything. So what I was saying is while true, obviously we have not given any statement to be true, but while true is just a default use if you just want to have a loop run and break it manually. You don't want to have a function that is breaking, so it's not breaking automatically on its own. You are going to break out of that loop by yourself using obviously the break function. So I'm going to say while true, do this. So it's going to now try this and just going to continue looping. Let me just run it. Let me just run it so you see it yourself. Let's say want to test f. You can see it gave us value error and then now asking us to put in our input again, passing k. Same thing, it will prompt a value error, but it's still asking you for an input. So it's being persistent. We don't want our program to crash. We just want that whatever happens, we must get an input from the user. So we get another input k. It's still going to ask for the same thing. But now what is going to happen if, let's say, we were to pass a digit? Now, before when we run in a number, our program prints out that number, which is what we want the program to do, to print out the input that we got and then dissolve itself, end the program. But what is going to happen now if we were to, I don't know, pass in an integer? Let's pass in an integer. It's still asking us for an input again. The only difference that in this case it's not giving us any error. Let's try, maybe there was something wrong with the number imputed. It's still asking us for an input again. So okay, I see the error I was talking about, keyboard interrupt. That is the error. Keyboard interrupt error. That is Control Z. Okay, so the way to handle this specific error is now it's the same way we're going to handle that name error we got at first, even though we've already handled it. But this is another way to handle that name error. So if you remember this prompt I gave you, I said we're going to cover try, we're going to cover except. We have done this two already. Now the last thing for I mean the next thing for us to cover is this else statement. So hi Ella, if you have done conditionals, if you have done loops, which are the last 2 days of courses we did before today, that was I think Wednesday and Thursday, I believe Thursday and Friday, I cannot remember. If you have done conditionals and loops, I'm sure you have heard of this else statement before. Now, in here in exception handling, it's kind of similar to the way it functions in those other statements and those other functions. But the difference here is that when you're working with else statement in exception handling, you're saying try this code. So you're giving it a code to try. Now, what if we got an error? If an error was retrieved, you're not going to say handle this error in this way. That's when you're now calling your except block. You're saying either dissolve the program or prompt the user again for another input or push out this input, letting the user know what they did wrong. However, you can be creative with it. You can do set a default. It depends on what your program is, honestly. But what now happens if the user's input was true? Whatever happens that if an error wasn't gotten, this is where the else statement comes in. The else statement is what is going to handle everything that wasn't in your that sorry what I say. The else statement is what is going to handle everything when the condition is true, when there was no error in your condition. So remember when we got that name error earlier, when we got x was not declared. So let's come out of this while loop now. Let's just remove this while loop and we'll just visit it again. Let's run our code again. Let's run our code. Let's get that name error we got earlier. Let me just get us out of this indentation quickly. Let's say this and let's run it. Now we're supposed to get, I want to get that name error we got earlier because we've already solved the error. We've already solved it. But let's raise that error again. So if we pass J, is going to raise a name error saying name X is not defined. That means we don't have any, we're trying to print a variable that doesn't exist. Basically, that's what that error means. You're trying to print a variable that doesn't exist. So how can we handle this variable using the else? It's very, very, very simple. We'll just say else, and we're going to indent this print under else. So let's move up. Now if we run it, this is supposed to automatically solve that name error, because basically what we're saying is try this code we have here. If an error was caught in this code, print this. But if no error was called, do this. So we're not saying that we're no longer saying that whether an error was caught or not, do this, because we're handling it. So if we run it, let's pass in L. You can see it just printed a value error. We no longer have that name error. So the else statement is going to hold every single thing. Like the only thing time the else statement is going to run is if no error was caught. I don't know if you understand what I'm trying to say, but that is everything else statement. Now, this next two things, although we're supposed to be using Harvard's own curriculum, he didn't cover this race and finally in his course. Let me go back here because I think I've finished most everything he covered. Okay, this one he just defined the function of himself. So that while statement we just created, he just includes the entire function. You already know how to work with function, so you can do it on your own. Just that while you can see the exact same code we did. We said while true, try this except else break return, because you have to return out of a function so you'll be able to access it when you're not running inside the function. Then he just enclosed inside the function called get int, and then in his main he now access the function here. So x is equals to get int. Once x is equals to get it, it's now going to say x is equals to whatever you get and whatever is returned from this function. If nothing is returned, then x is going to be blank. So x is going to be whatever is returned. Okay. So let's see what else. Like that's basically it. Okay, he talked about this pass function. I don't know if you have been watching my video. If you're watching my video, I'm obsessed with pass. Pass is basically when you're saying, I know something is supposed to be here, but I don't want to put anything in there right now, so just forget about it. That is basically what pass is. If you watch my programs, if you watch my videos a lot, you know I'm obsessed with pass function. Whenever I'm explaining something and I don't want to touch on that topic, I don't want to impute any statement yet, I'll just pass it. So whenever you put pass, you're not saying yes, you have, yeah, for example, in exception handling, you're saying, okay, you have caught the error, now forget about it, don't do anything, don't print anything, don't ask the user for anything again, just collect it, keep it to yourself and move on with your life. That's what pass is saying. Like, you just think of it as your English word. Pass, forget about it, go your own way. But yeah, that is basically we're done with his own. So let me just give you this more because these are things that are also coming. So we're done with Harvard's own course already. But now here you have the raise. So what the raise does now, raise is when no error was caught, or at least no what's the word I'll use? Like no Pythonic error was caught, but you want this error to be caught. I don't know if I'm making sense. Okay, let's take an example here. Let's take an example. Zero. Let's run this code. Let's run the code first. If we were to impute zero, our program is going to run fine because according to Python, zero is an integer. But what if to us? Okay, what am I saying? Okay, so Pythonically, zero is an integer. But what if in the program we're currently working with, to us, zero is an error? We don't like zero. What do? We can raise an error. So because the output we want to handle it the exact same way it's handling every other error. The other way to talk about this, you can make your code longer by saying, should we do that? Let's do it. We can say if x is equals to zero, maybe I don't know, print an error. Let's just copy this print we did here because I hate writing. Print an error, and then once we end our program, we can either break or we can exit. So we'll just close the program completely. Because if we break, if there's any other code outside the program, it's going to continue running it. So we can exit, run without debugging. Let's put in zero. So you can see it did the exact same thing our except block is doing. So what is the point of our except block is doing? So what is the point of rewriting the whole code? It's just going to make you occupy more memory. It's going to make your code look bulky and it's going to get a bit confusing. So how can you handle this? Let's get rid of this code we just put now. We just imputed now. So we can say if x is equals to zero, we can raise an error. You can raise a specific error since we're catching a specific error. But if I just threw in except, I can just raise and just leave it. But we're catching a specific error, value error. So we're going to raise value error. You can pass in extra parentheses there, but let's just run it like this. So you can see 0 according to Python is an integer. But now that we have raised an error, now that we have told Python by ourselves that this 0 is an error to us, Python is now treating 0 as a value that isn't an integer. There's another way to go about this phrase, or when you now define an, because I'm not fluent in it, if you may. And what else is on my this stuff? Okay, finally. So what this finally tag does is that after you're finished catching all your errors, you're finished handling all your exceptions. So I'm looking for something. After you finish catching and handling all your exception, it's now going to run a code that is going to be common to every single one of them. That is, whether an exception was caught or not, this code is going to be run. So let's say I'm looking for something. Um Alright. So let's say whether an exception was caught or not. Whenever we call that finally, it's now going to run every single thing. It's going like every single thing is going to run it. So let's say for example, we just wanted it to print done so that whoever is using our program would know, okay, finally the program has ended. So I mean the name literally implies it. So we'll just call final and we'll just print what it is we want to be printed. So just say print done. So let's save this and let's run our program. Let's pass in a normal integer. It printed the integer out and then it printed done. Now let's try getting an error. Let's try handling an exception. It still printed out the error prompt, value error, and it printed done. So with this, we are done with everything exception handling, at least all the basics of exception handling. I don't know if Shay is still here with us, so we can just jump into regular expression. But before that, do you have any questions on exception handling? Okay, I don't think Shay is here anymore. And I don't think you have any. I think you understood the regular expression very well. And I guess we should call it a night.